Tyler Cooks from the computer engineering team. So our objective was to create a matrix calculator that was going to be able to do addition, subtraction, transpose, and the determinant with a 5x5 matrix. Unfortunately, because we couldn't figure out how to communicate properly with the UART, although we did at some point get the transpose right, when we try to add other functions, it fell apart. But right now, I'm just going to show you what we do have and what we try to accomplish. We did try to separate everything into a top module. This will be our top module. Right now, I'm going to show you the transpose. So for the transpose, we have a shift register right here. So one of the techniques that we try to do, because errors that were popping up, even though our test benches were working, when we tried to communicate through the terminal, would sometimes give us erratic numbers, and we thought that was a timing issue. To get around that, we tried to use a shift register that didn't really depend so much on timing. It just, if something got inputted, we'd shift it, and we were able to put everything into one variable. In which case, like for the transpose, what we had to do is reorganize it. So you see that it puts into a shift register, and then when it's full, this tick is only here for the sake of to counting down to make sure there's 25 elements that get sent in here. And then when it's full, the matrix will get ready, and then put it all into the proper order. And then this is where we'll have a signal that is supposed to come from the UART to kind of take these values away one at a time. So like, and we put that in a case statement. So the first element would come in, and it would send the top one, the first element in the UART or in the terminal. So right now, I'm just going to show you how well that works. So as you can see, these bottom values won't be filled until the matrix is full, in which case it will we use this is a sequential statement to just automatically put it into another matrix for bigger value, in which case we can send it out. So this is the test bench, and so you can see, of course, the test bench, we just ordered it 1 through 25. So 1 through 25, you see the order. And then for the D out on the 25th one, this would be right here, the transpose. And so you can see if it went 1, 2, 3, 4, 5 by rows, right now it's going to be by row 1, 6, 11, 16, and 21, which you would expect if there was a transpose. Then the next fee should be 2, 7, 12, 17, 22. 2, 7, 12, 17, 22. As you can see, our transpose works perfectly. Now, because everything else was relatively the same, we would expect like the addition and everything else to act in the same way. So we would put 2 shift registers to get 2 of the matrices, in which case we would add them together and then shift them out the same way. Anyway, although our project is incomplete, we did try to put a lot of effort more into the UART communication, because we knew that once we got that down, everything else would kind of fall into place. Unfortunately, everything going on, we ran out of time and we weren't able to complete the project the way we wanted it. This is what we have so far, and is it?